Hi, Miss Marion here. We are going to be doing lesson 7 for today. Let's go ahead and turn to page 121. And you're going to give yourself a sentence about the I can statements. I can use an angle measures and side lengths to conclude that two polygons are not similar. And I know the relationship between angle measures and side lengths are similar polygons. We're going to go ahead and give yourself a sentence and then also a number. So number 1, I don't remember. 2, I kind of remember it. 3, I do remember it, but I don't feel comfortable teaching it to my friend. And then 4, I can go ahead and I know it and I can teach it to my friend. So go ahead and do your sentence and your number. All right, let's go ahead and turn to page 59 in our workbook. And this is the first thing, all, some, or none similarities. And what I want you to do is go ahead and answer the following questions. Choose whether each of the following statements is true in all cases, in some cases, or in no cases. So number 1, if two figures are congruent, then they are similar. Number 2, if two figures are similar, then they are congruent. Number 3, if an angle is dilated with the center of dilation at its vertex, the angle measures may change. Go ahead and answer that with all cases, in some cases, and in no cases. So go ahead and pause at this time. All right, let's go ahead and go over the answers for this starter. So if we look at number 1, if two figures are congruent, then they are similar. This does happen in all cases. Congruent figures can be taken from one to the other by using a transformation, rotation, and reflections. With similar figures, the only other difference is that they use a dilation. So we can actually use the transformations to go ahead and make the two the same. So yes, if two figures are congruent, they're also similar. Number 2, if two figures are similar, then they are congruent, kind of going backwards. This happens in some cases. Similar figures can be taken from one to the other using translation, rotation, reflections, and dilations, but two figures can be similar that are different sizes. And so just because they're similar doesn't mean they're exactly the same. We can actually have two different things, or one's bigger and then one's smaller. And if you have one bigger and one smaller, then they're not congruent. And then the last one, if an angle is dilated with the center of dilation at its vertex, the angle measures may change. This is in no case. If you think about it, the dilation will take the rays and make the angles longer, but it will not change the measurements themselves. And we'll actually kind of look into that a little bit further for today. So go ahead and change your answers if you need to. Write those down on that first page, page 59. All right, this activity starts with page 59 and goes to 60. And so we can kind of look at that. And on page 59, it says, Priya says these polygons are similar because their side lengths are all the same. Claire says these polygons are not similar because the angles are different. Do you agree with either Priya or Claire? And then explain your reasoning. Go ahead and pause the lesson at this moment. Go ahead and answer that question. Do you agree with Priya or Claire? And then give a reason for it. Write that answer to the question underneath this question on page 60. Go ahead and write a sentence as far as what your answer would be. Go ahead and pause. After looking at this, personally, I agree with Claire. And the reason why is, yes, the angle measures in the similar polygons are the same. Okay, if we're thinking about something similar, those angles all usually stay the same as the side lengths that kind of change. And if we look at these, we have over here, we have a square and it has 90 degrees everywhere. Okay. Over here, we just have a polygon. There's 60, 120, 60, and then 120. These angles are not the same as these angles over here. So no, they are not similar. And so Claire is actually the one that is correct. Let's go ahead and look at number 2. Jada says these rectangles are similar because all of the side lengths differ by 2. Then Lynn says these rectangles are similar. I can dilate AD and BC using scale factor of 2. And AB and CD, I can dilate those using a scale factor of 1.5 to make the rectangles congruent. Then I can use a translation to line them up, the rectangles line them up, and show that they are similar. Do you agree with Jada or do you agree with Lynn? Go ahead and write your answer underneath this question on page 60. Answer that question, write a sentence there. Which one do you agree with and why? So go ahead and pause right now. All right, after looking at both of these, I disagree with both Jada and Lynn. So Jada is right that the side lengths all differ by 2, but the scale factor between the shortest side and the rectangles and the scale factor between the long side are not the same. So you have to have the same scale factor all the way around to make it work. And then, so this means, because we don't have the same kind of scale factor, this means that the 2 rectangles are not similar. And then Lynn is not correct because the scale factor for dilating one set of sides cannot be different than dilating a scale factor for the other set of sides. So again, your scale factor has to be the same all the way around for something to be similar. On page 61 in your book, this is 7.3. And it says, find someone similar. It says your teacher will give you a card. Find someone else in the room who has a card with a polygon that is similar but not congruent to yours. When you have found your partner, work with them to explain how you know that the 2 polygons are similar. Well, right now we're not in class, and so you really don't have a partner, and you really can't go ahead and find someone else that's the similar itself. So what I decided to do is actually go ahead and kind of put everything on this slide. And what you need to do is you need to match the letters A through J with each other that are similar. So you need to find out letter A, which one is similar with letter A, and put those together. And write the answers down underneath this on page 61, in between the 7.3 and then are you ready for more? So you'll need to go ahead and pause this and figure out why they're similar and kind of why. Then is 9. All right, here are our answers, and I kind of color coded it to go ahead and go along with each other. And if we look at it, we have A goes with I. And let's look at the sides. So let's kind of put the 8 and the 12 together. So if we do 8 over 12, and we reduce this down, this is going to reduce down to 2 over 3. And I could have done the fraction the other way around, 12 over 8 reduced out of 3 over 2, but we want to keep it as fractions, even if it's an improper fraction. Now let's do the same thing with the other side. We have 6 over 9. Let's take the 6 over 9, let's reduce that down. That also reduces down to 2 over 3. So the scale factor for these two is 2 over 3, and we've shown that that went ahead and worked. The other thing that we looked at was the 90 degrees. So all these are 90 degrees, right? So the angles need to be the same, but then the side lengths, they can actually have a scale factor between each other. Let's look at B. So B, okay, goes with E here. So first of all, let's look at the angles. We have 60, 60, 120, 120. 60, 60, 120, 120. Now let's go ahead and let's do the same thing with the sides. Well, the sides, they're 3.5 over 4.5, okay? And if we go ahead and we look at those, and we can go ahead and put those together. So let's do 3.5 over 4.5. This is the same as 3.5 over 4.5. 3.5 as improper fraction is 9 over 2. 4.5 as an improper fraction is 7 over 2. Okay. If we take this, divide it all out, all that fun jazz, we are going to get 7 over 9. Okay. And if we look at it, all the sides are the same. So if I do again with a different set of sides, we're going to get the same answer as 7 over 9, which is the scale factor. Now, I can also do it flipped, reduce it all down, and get 9 over 7. But again, the 9 over 7 would be the scale factor for both of those. Let's go ahead and let's look at C. So C goes with H. Same kind of thing about the one that we did before. If we put the sides together, we're going to do 7 over 8. So 7, 8. And that is reduced down as simplest way possible. And if I do 7 over 8, those scale factors are the same. So then, yes, they're similar to each other. Again, I could do it flipped as 8 over 7, same kind of thing, but we'll get the same stuff. Let's look at D and G. So let's go ahead and let's put the fraction together. And this one, if you look at it, one of them's kind of turned. We're going to put the shortest sides together and then the longest sides together. So we're going to go ahead and we are going to do 3, shortest with the shortest. So we're going to do 1.5 divided by 3, that's 1 and 1/2, divided by 3, so 1 and 1/2, divided by 3, press enter, and we want to make sure it's simplified all the way down to 1/2. Again, let's do the other two sides. Let's put the bigger sides together, 5 and 2.5. So we're going to do 2.5 divided by 5, okay? And that's 2 and 1/2 divided by 5. Let's reduce that all the way down. Again, we get 1/2. So we have the scale factor. Again, we could have done it flipped and made the scale factor as 2, okay? But again, we still get the same scale factor. Let's look at F. Okay, that's this one and J. So all of the angles, so we have 50, 50, 130, 130, 50, 50, 130, 130. All the angles are the same, and then we can also do the same thing with the scale factors. And as we can see, all the sides are the same. This is a rhombus. The only difference between a rhombus and a square, or a rhombus and a rectangle, is that the angles are not 90 degrees. But if we want to go ahead and we want to put it as a fraction, it's going to be 9 over 10. So we have 9, we have 10. And I could do 9 and 10, right? And so our scale factors are going to be the same. So the way that we looked at it is we checked to make sure that the angles are equal, but then the sides are a scale factor. There's a scale factor with it. So what was our goal to go ahead and learn for today? So similar fingers have congruent corresponding angles, so all the angles are the same, and proportional corresponding sides. Proportional, remember proportional, that means we can make a fraction out of it, right? And scale factors are fractions. So similar fingers have angles are the same, the sides make fractions, okay? And then for some figures, like rectangle or square, it is sufficient to focus on the side lengths. Since we know the angles of a square and a rectangle have 90 degrees, so we just kind of focus on those sides. And then for some figures like rhombuses, it's okay to go ahead and just look at those angles, because with a rhombus, the angles are going to be the same, and then again, the corresponding side lengths are automatically proportional because all of them are the same, right? We just kind of showed that. So this is actually our goal for today as far as understanding similar fingers. We look at the angles have to be the same, and then the side lengths, they have to be proportional or they have to make a fraction. Go ahead and turn back to page 121. Go ahead and write a sentence about how you feel about today's lesson. So I can use angle measures and side lengths to conclude that two polygons are not similar. And I know the relationship between two angle measures and side lengths in similar polygons. And I can understand that relationship. Go ahead and write yourself a sentence and a number. So 1, I don't remember. 2, I kind of got it. 3, I did get it. But then 4, I can actually go ahead and teach it to my friend. Make sure you go ahead and do the practice problems that go along with this. So it's 8.2.7 practice problems. Again, every practice problems, they have 3 attempts. Okay, so make sure you do it over again and make sure you understand that information because we do have a quiz next Monday. Yay. Okay, so make sure you understand and know how to do those things. Have a good day. Bye.